Okay, so let's discuss about some. See, in computers, always the operations operate on the binary numbers, either zero or one. Okay. Uh, for example, consider I have a two-bit binary number. Two-bit binary number. Okay. Two-bit means it can have only two bits. Okay. Zero one is one number. 101 is one binary number. 11 is one binary number. And 00 is one binary number. It can have four different states. You're able to understand, right? This is called as two-bit binary number. If you're not able to follow, please tell me. Okay. So consider a two-bit binary number. It is having only two bits. Okay. It can have these many forms: 00, 01, 10, 11. 00 is nothing but zero. If you convert it to decimal, 00 is nothing but zero, and 11 is nothing but three, and 10 is nothing but two, and 01 is nothing but one in decimal. You're able to follow it, right? Or I will tell you how to. See, you're aware of binary number, right? It will have ones or zeros. Okay. Consider you have a binary number 110. Okay.
Yeah,
It, okay. So it can be converted into decimal by using 2 into 2 to the power of 2, 2 star, 2 power of 2 plus 1 star, 1 power of 1 plus the last number is 0 star, not 2 power, sorry, not 1 power, it's 2 power, 0 star, 2 power 0. See, this is in decrementing 2 to the power of 2 into 2 to the power of 1 into 2 to the power of 0. And these numbers are 2, this is their position. This is how even decimal numbers are organized. Okay. So if you take a two digit number here, 0 1 is nothing but 0 into 2 to the power of 1, 0 star, 2 power 1 plus 1 star, 2 power 1. Sorry, 2 power 0. So if you add it, this is nothing but 1. 0 into anything is 0. And 1 into 2 power 0 is nothing but 1. 1 into 1 is 1. So this is nothing but 1 in decimal. Okay. If you take 1 1, okay, 2 into 2 power 1 plus, it's not 2. Sorry, I'm making mistake in hurry. 1 into 2 power 1 plus 1 into 2 power 0. Okay, which is nothing but 1 into 2 is 2 power 1 is 2. 2 plus 1 is 3. 1 is nothing but 3. So this is the maximum number it can go through with 2 bit. If both are high, this is the highest number. Okay. So what I'm trying to tell you is 2-bit number can have 3 as the maximum number. Similarly, 3-bit number can have 7 as the maximum value. 3-bit maximum value is what? It can be all high, 3-bit. Okay, all high. So if you calculate into 2 power 2 into 2 to the power of 1 into 1, if you add all these things, it becomes 7. Okay. Similarly, for a 4-bit, so it will be 2 to the power of 4, which is 15, which is 1111. Similarly, for a n-bit binary number, it will be 2 to the power of n minus 1 as the maximum number. Okay. So what about our char data type? Char is a single byte, right? Single byte. So which will be 8-bit. I'm talking about unsigned char. Okay. yeah, 8 bit. So it can have 2 to the power of 8 minus 1, 2 to the power of 8 minus 1 is equal to 255 as the maximum value. Okay. In case of signed char, first bit is used for sign. Okay. So the remaining 7 bits are used to represent the numbers. So it is minus 2 to the power of 7 including 0 and 2 plus 2 to the power of 7, which is nothing but minus 127 to minus 128 to plus 127. You can calculate by yourself. Okay. So I can decide. You can calculate like this. A character can have a range from 0 to unsigned char can have a range from 0 to 255. Signed char can have a range from minus 128 to plus 127, including 0. Similarly, you can calculate for other number. Okay. Consider int. Okay. By default, it will be short int. Okay, for a short integer. If the integer is normally it takes 4 bytes. 4 bytes. Okay. So if it is a signed int, first bit is used for sign. So the remaining bits are used for representing the numbers. Okay. 4 byte means how much? 4 8s are 32. 32 bits. Okay. Signed int is a 4 byte number, which is nothing but 32 bit. First bit is used for sign bit. So remaining, you're able to follow it, right? Am I disconnected? Okay. So this way you can calculate the ranges of each data type, but by manually. Okay, this is how it goes. You can calculate the range of each data type by manually by in this way. So here, if you see this example, I gave an example of tutorial point, right? Okay. So whenever you see any link, see the code there. Okay. I see. So this is they have given the ranges here. Character. Okay, minus 128 to plus 127. Short char minus 128 to. They have different time. Don't worry about all the types. Okay. Whatever you needed, just use them. Okay. And don't worry about all the types. So these are the ranges. So what they are telling is this is a macro. This is a macro which tells the minimum value of the char, maximum value of the char. This is a predefined macro within the C language. It's already there. Okay. This has got these values. Okay. For example, character minimum as a minus 128. Character max is a macro with plus 127. So they have given a sample code here. Okay. If you see the sample code here, let us copy paste to C++. This is a C. We are learning C. Okay. Let us. Okay. This is similar to C. Okay. I'll print some of these values. Actually, code stdio.h. We'll delete this line also. We have int main. Okay. Int char type varies from %d to %d. So we have a predefined macro to use here. Okay, I can tell char min. I can tell char max. So I will close this. I'll comment out all the other things. Okay, you can practice by yourself. So this is the range of the char type. Let's print this. Okay. Let's compile this first. I hope it will compile. Yeah, it's compiled. You're able to follow, right?
Yes, yes.
Okay. So I printed. The character type varies from -128 to +127. So similarly, they have a predefined values for all these things: signed char max, signed char min, and short min, short max. So this way we can print out that this is defined in limits.h. These are the limits of the C language data types. Okay, it will have all the limits. Even it will have a limit. What should be the size of the maximum size of the file name? What should be the maximum size of the directory name? All the limits will be mentioned in this limits.h. You can do this
So when we
assignment by
want to use that limits and when we want to use that float,
float in the sense float is a decimal type, right? So for example, for example, the result of the division operation will be a decimal number. Use float for that. Okay, in float, sorry, float. For example, area of a circle will be a decimal number. Float pi is equal to 3.14 and declare the area. Okay, and let's say float radius maybe 2.5 or 3.5. That is also a float. Float radius is equal to let this be 5 centimeter radius. Okay, 5. Float radius is equal to 5. So let us print the area. Okay, area is equal. Area should be float, right? Because the result is float. So if I declare it as int, also it will compile and work. It's not an issue, but it will discard the points, the numbers after the point. Okay, area is equal to pi star radius star radius. So here we are handling with the floating point number, decimal. I mean, the floating point. They are called as floating point numbers. Okay, they have some precision. They are highly precise numbers. So we use a float. Okay, it should be float. So we use float. Okay. So consider we need to use much more precise values, like 10 numbers after a point, 15 numbers after a point. During that case, we can use double. Okay, if you this is how the use case works. So again, coming back to the history of the numbers, float is a single precision number. Single precision. I heard. I think you are aware of IEEE single precision number. Don't get into so much detail. I'm just telling you. Double is a double precision IEEE number. Okay. So float is a 32-bit and double is a 64-bit. So you can store large data in the large precision in the double type than the float type. So this is how it can be used in our coding. You're able to understand, right? I hope all of you are following me.
Yes, sir. Yes, sir.
Okay. And try to do the remaining part of the assignment by yourself. Okay. Print ranges of all the possible data types. Instead of cout, you can use printf here. And I will give some more assignments today, interesting assignments with respect to operators.